get into adding rational expressions when we don't have a common denominator, we're going to need to build a common denominator. And right over here in the use structure box, you can see an example with 1/16 and 1/15. The common denominator would be, let's see, 30. 30 would be the least common multiple between 6 and 15. So notice how you don't need to just multiply the two denominators together to get the least common multiple. That's what they're saying right here, that it's not 90. Since 6 is 2 times 3 and 15 is 5 times 3, they already had the 3 in common. So to make the first fraction and the second fraction to get a common denominator, you only have to multiply by what each fraction is missing. So see how right here in green, they multiplied the 1 times 5, and over here in red, they did the 1 times 2. We didn't have to worry about the 3 because they already had that in common. So let's take that concept over to here. As we check the two fractions, if we're trying to add them, we need to begin by seeing what factors would be used to make x squared minus 1. So I'm just factoring it to x plus 1 times x minus 1. And the other denominator, x minus 2 times x minus 1. That is this denominator in factored form. So with my highlighter, if you have a highlighter, a couple different, maybe 3 different highlighters available if you could, you could see that they already have the x minus 1 in common. So the one on the left has the x plus 1, but the one on the right doesn't. It has an x minus 2. So what we're going to do is we're going to try to get all 3 colors or all 3 factors involved in both fractions. So what I mean by that is the one on the left has green and yellow but not blue, so it's going to need blue. The one on the right has blue and yellow, but it needs green. What we're going to do is we're going to multiply the top and bottom over here by the green x plus 1. Okay, so we're going to multiply top and bottom by x plus 1. And on the left, we have the green and the yellow, but we need the blue. And whatever you do to the bottom, we're going to multiply by x minus 2. You have to do the same to the top. So we need to multiply x plus 3 times x plus 2. X plus 2. So now both fractions have all 3 factors. X plus 1, x minus 1, x plus 2. And the other one has x minus 2, x minus 1, and x plus 1. So everybody's here. We have all 3 factors in both denominators. Now to keep going here, we're going to need to see what we get up here. Let's go ahead and FOIL this out to see what we get when we multiply x times x squared. I'm just going to FOIL this. On the outside, you get a 2x, and on the inside, you get a 3x. So that's going to make a 5x there. And I'm multiplying this out, and then I'm going to distribute the 2. The reason I'm doing this is then we're going to have to sort of combine like terms up here with everybody in the numerator. So we don't want to leave the numerators in factored form. We want to get them in standard form. So back to where we were. I still had to do the 3 times 2 to make 6. For the other numerator, you're just going to distribute the 2 and make 2x plus 2. So we're going to add straight across the top. Any like terms can be combined. So x squared doesn't have a like term, so just going to list that. 5x plus 2x will give us 7x. And 6 plus 2 will give us 8. So all that's in the numerator, and then we have x plus 1, x minus 1, x plus 2 down in the denominator. And you do not need to, I'm not going to have you multiply this out. You don't have to worry about foiling that. Just you can leave the bottom in factored form. So that is finding the sum of rational expressions. You're going to do the two triad problems here at the bottom. And then later in the lesson, we'll talk about how you subtract, finding a rate, and then we'll get into some compound fractions next time as well. So let's just finish up the two triads that go with example 3, and then you also had example 2, the triad to do, or sorry, example 1, you had the triad to do as well. So that's it. We'll see you next time.